I am a professor at Drexel University, the safety department at CME Hawk. We are in the architecture engineering domain. Similar to our first speaker, Alan, you mentioned about how we provide a topic and then started to think about that on the trip here, right? So I started by thinking about talking about a new National Science Foundation project. We just got awarded. The title is Building Up Medicine Cabinet. It's talking about how we develop different kind of services for them. And on the way here, I was thinking I'm not going to talk about too much about the technology stuff. I'm actually going to talk about the building doctors. I want to talk about this group of humans that has a strong impact on our buildings, on our day-by-day life, how building operates, the building performance. Yet we often ignore them as a group of humans. We often group them into the building technology side, okay? So who are these building doctors? My research is mostly about full diagnosis. So initially, I was thinking about the commission engineers. When you need something, you call them, they come in, they diagnose your building to see whether there's any faults, any problems. They're more like doctors, right? But the more I think about them, the more I think, you know, it's everybody, right? For the residential building, you guys are the building doctors for your own house. Although we know very little about our own house, I mean, this group might be different, but a lot of people have no idea about how mechanical systems really work. So when you find something wrong, right, you go to service providers. They are somewhat experts, know some things, you know, they fix your stuff. Sometimes it's not always the case. I really always have pity on the people who come to my house. Because, you know, being a person who teach HVAC, right, I try to find out what their background. I found one of the service person to my boiler just switched from history major to HVAC, right? So I got to give him a lecture about how boiler works, right? But for most of the commercial buildings, you have more expert people on site, operators, you know, you have energy auditors, you have service providers. The knowledge level range really from low to high, right? For the operators especially, it's a very interesting group of people. You might have very experienced people. The facility manager at Drexel, he is very knowledgeable. He knows a lot about control, about HVAC. But you also run into people who might just have a high school degree, get some years of training, you know. So really have a wide range of situations. Unlike in the medicine domain, you have the certification, you have many years of training and practicing, right? And those are the people who work on your buildings on these complicated mechanical systems. What kind of tools they have? Occupants, you have thermostat, you might have some panels, most of us ignore them, right? Operators, you have many different tools. Whether they use them or not is a different story, which we will talk about. They have building automation systems, they have a lot of alarms, a lot of information. We actually routinely trying to sell them more tools. That's my research, right? I develop more tools and try to give them more information, trying to, you know, tell them what to do. Service providers, on the top of them, they have also handheld devices, very specific devices, commissioning engineers. This is a group who has the most knowledge, honestly. You might run into PhD degrees. My student, after developed the full diagnosis tool that we are very proud of, he decided to open his own company. He has 3 PhDs working with him. So they're very knowledgeable people. They might have very advanced tool as well. So I was like, can I take a look and think about human and the system relationship? So when you look at the relationship between the building and those so-called doctors, right? What do we have? Buildings provide a lot of measurements. So they are data, okay? Data then went through a bunch of systems. The most typical system is the building automation system. Now remember, the building automation system is not designed for human. They're designed for control, okay? So they are designed for this machine-to-machine kind of communication. The control company wants to do that without your interference, okay? And then we try to say, okay, you have all those measurements. Can you provide more information to human at this point? We have some kind of energy management system, can be part of EAS, can be an energy information system on the top of that. People who do building analytics, trying to sell more tools, all those fancy interfaces. So in the end, you have a bunch of things. You might have a lot of time series data. You have a lot of alarms from building automation systems. We define all those complicated building performance indices, and we try to make sure that the building operators have those indices, trying to help them to understand. I have spent 20 years on this little category, right, doing fault diagnosis, advanced control. My goal is, okay, now I provide you all those information, data, information. What I really want you is to make the right informed decision as a building doctor. I actually want you, based on my fault diagnosis conclusion, you go back, you fix stuff, like that light bulb, right? Send alarm, needs to be replaced. You should go and replace it. What happened? They don't understand what the heck are you doing, okay? And the building operators decide to, you know what, I don't know what you're doing. I'm going to override. I think I know better than your machine, right? I'm going to override your supervisory control. I'm going to set the set point based on my understanding, right? And then I'm going to shut down all your alarms because I'm overburdened. Talking about occupational health, that's a major issue for operators. Too much information, I don't understand. Shutting down all the fault diagnosis, I don't know what you're doing, okay? And I don't trust you, talking about the trust issue as well. Very interesting. So after 15, 20 years of developing technology, I'm at the stage to look, I need to understand this human better, because no matter how much information I provide, it doesn't get translated into decision, have no impact on my building energy consumption, have no impact on my building performance, right? So I stepped back. I was like, who are them? What kind of profile? What kind of situation they have? I found 2 papers over the literature about this topic, okay? And I've been working with both of them. I take pride in that. One is from Dr. Michael Bucker, a faculty from CUNY. He has been the past chair of ASHRAE's TC about building operator. He has many, many years experience training the operator. And I'm stunned to see what he wrote here. Their study group believes they know what they do not, what others do not. That's a very key thing. All of us who work with facility people feel, you know, they don't believe we know anything about HVAC system despite that we teach HVAC. And that's their attitude toward the academia, the researcher. Let it be how they handle other people, right? Especially that I give them credits, right? They do know their specific side. If this is a group of people who have worked many years, right? And which we may not. And just providing a list of recommendations have no impact, all right? Because they, as a human, need to understand, need to build up this trust with your technology. And I have to say, we did very poorly in building up this trust between technology and the building doctors. Because it's a hard area, because we have failed in terms of accuracy, the alarms, all those kind of things. I think it's time to rethink about this topic, right? So I found another very nice report from ASHRAE Project 1633 from a group of MIT PhDs decided to do business. So I'm going to put all those profile there, and I'm going to point out some of the most interesting stuff, right? You will see that they're overloaded. You have an engineer who take a bunch of people, pretty much mostly just put down fires. They have no time to look at your advices. You may have very experienced engineers as consulting engineers. They actually could take advices, okay? You have people who completely don't want any advices, because if you tell them what are the problems, they have to do more work. Okay, this is a very typical mentality among building operators. I don't want to get any more information. My hands are too tight. And then you also have people who actually are developing their own Excel file, trying to understand more about the building. So it's a very, very interesting, diverse kind of situation. And a lot of them tell you that they don't want full diagnosis information. Very discouraging for my research, of course, right? Then if you look at how they make decisions, they are the people who tell you or who decide what kind of HVAC system are going to be upgraded, what kind of maintenance you need to do. They're the person who really determines the building performance. How do they make decisions? They mostly depend on themselves, or they talk with other engineers. They ignore most of the other performance indices we spent so many years to develop and so on and so forth, right? And if you look at what kind of tools they want, they just want time series data because they believe they understand that, okay? If you really look at what they do, they take a lot of time. They don't have the time. They think they do, but they don't. Okay, so very discouraging, right? By the end of this actually project, that company, KGS, they actually developed a bunch of interface, a markup interface, and get evaluation. The final result is pretty encouraging because the most highly ranked full information, 2 of them are actually full diagnosis information. They just don't know that by presenting the faults in this calendar way, in a different way, they actually like it. Okay, so they have this perception about they don't want full diagnosis from previous experience. However, if you design the visualization differently, if you design the information differently, if you add more accuracy here, you could change their belief, okay? So I think as a researcher, we need to think about a bunch of questions. The first question is, are current building data good enough? Should we get more, okay? Should we merge different information to improve the accuracy? Secondly, what kind of information should we generate in order to change their decision? That's a key difference, right? We focus on information, but we really should focus on changing their decision-making process. So what should we hide, all right? Maybe we should hide a lot of stuff because they don't want to know, okay? They shut down all those alarms, okay? Like the car we drive, it doesn't tell me the engine's temperature. Because as a driver, I do not want to know. You figure that out yourself. Providing that information has no impact on my decision. What to review? Some things are very important that is not providing, like Liam's information about how soon the zoom can be quoted up. So that can change the decision, right? How to visualize. The same information, just by presenting that different ways, will change different decision making. So I'm going to fly through all my wonderful research about full diagnosis. We developed a lot of good technologies, but as I said, if they don't use it, there's no impact, right? And this is a very interesting talk about, coming from, I think, Liam, your workshop, talk about the new potential of data. All those new data come in that can potentially help us to improve the accuracy of our full diagnosis, our supervisory control. And I'm going to give 1 minute about my project, right? So we're starting to do this project, 3 universities led by University of Alabama. So 2 of our building engineers are working with 2 information scientists, and we team up with the KGS Buildings, who is behind that actually 1633 project and a bunch of other control companies. So we focus on a couple of things. One is we focus on how can we utilize all those non-traditional data by doing different data mining, machine learning strategies, trying to improve the accuracy of all those tools, all those informations, provide better information. But meanwhile, we really want to do a lot of survey studies, trying to understand those building doctors' mentality, what kind of visualization can help you to make a decision. What do you want? How can we change your behavior? We want to tell them so, but we are trying to figure out how can we change their behavior. So this is the first year of our project. So if Gucci you organize follow-up workshop, I hope that in the future we can report on some more interesting story around that topic. But mostly I want to raise the awareness of this group of people. They're not part of the technology. They're not part of the building. They're human as well. Their human behaviors have very strong impact on our building's performance. All right, thank you.